Hey guys, so in this video, we're going to discuss Leetcode 366, and it's a very common question asked in coding interviews. So for this problem, we're going to be given the root of a binary tree, and the binary tree is a tree that every node will have maximum two children, the left and the right, and we're going to find all the leaf nodes. So for example, in the tree of 1, 2, 3, 4, 5. So we have the leaves of 3 and 4 and 5. And then we're going to remove all the leaves and we can get a new tree, 1 and 2. And then the leaves is 2 and we remove 2 and then get a new layer of the leaf is 1. So we find all the layers of the leaves, which is like 3, 4, 5 as a first layer and then 2 as a second layer and then 1 as a final layer. So we have them in the output and return it. So basically for this problem, we're going to find the height of all the nodes in the tree, and then we can like have all the nodes with a height of 0, and then all the node with height of 1, and then all the node with height of 2. So how to get the height of all the nodes? So if it's a leaf node, then of course the height would be 0, like for example, for 3, 4, 5 in this case. And then for every node, its height would be the maximum of the left child and the right child plus 1. So in this case, if the node is 2, then the maximum of the left and the right is still 0, and 0 plus 1 would be 1. And for the root node, it will be the maximum of 2 and 3, which is 1, and the plus 1 would be 2. So the root node would have a height of 2. So once we get the height of all the nodes, and we will know like for the root node, it will always have the maximum height. So we can know like the maximum height in this tree would be 2. So we just find all the node with height from 0, 1, and 2, and then like have them in the output, and we can get the result. Okay, so let's code it up. So in this question, we're gonna use DFS algorithm to find the heights of all the nodes. So let's define the DFS. So and then for the height of the node, it would be either it would be 1 plus the maximum of the right plus the maximum of the right and the left, max of DFS of the node dot right and DFS of node dot left. All right, and we also need to consider the edge case because we assume like the node always exists and have the right and the left, right? So what if the node doesn't exist and then like the node dot right would be have an exception? So like if not node, then it means the height would be 0, right? Because it have no children. All right, and we can have the and we also need to define collection dictionary to store all the heights of all the nodes from collections import. We have the heights dictionary. So in the dictionary, we're gonna have like the key as a node and the height as a value. All right, and we store it in the dictionary inside the DFS. We return the height. All right, so this would be the typical DFS algorithm used in trees. So I would say for 90% of the tree problem, we're gonna use this algorithm. So just memorize it if possible. All right, so now let's just do the DFS over the root. And then we're gonna have just populate all the, so in this case, we're gonna just populate all the height for all the nodes. All right, now we can know the max height would be the height of the root. So yeah, so this would be the maximum height. And let's just so this is maximum height, right? So let's say if the root node has a height of 3, then we will have like all the nodes from height of 0 and then 1 and then 2 and then 3. So we can populate the response object first so that we can append all the result nodes into the response object. So now this is a response object which we're gonna return, and then we just need to find all the nodes with the different heights and then put it in the response object. All right. So let's just say for node and the height in heights, we just look through the dictionary. And we'll just append the node height -1. See if we need to have -1 or not. So it will be 1 plus maximum. So if it, let's see. So for node 4, if no, it will be, yeah. So in this case, like the lowest height would be 1, because if it's node 4, then we're gonna have like the left and the right is none. There's no children, so the height would be 1 plus 0, so it would be 1. So the maximum would be 1. So yeah. So in this case, like the minimum height value we stored in the dictionary will be 1. So that's why we need to -1 here. Yep. And the dot app append. Wow. Yep. All right. And then let's see how it goes. Yep, it looks good. So for this case, the time and space complexity wise, the time complexity would be order of n, because we're gonna loop through all the node in the tree, and we're gonna use DFS, which gonna have a core stack of like n nodes. So core stack of n cores. So the time complexity would be order of n, and the space complexity would be order of n for the core stack. And yeah, so this is the end of the video, and I'll see you guys in the next one.